Geologists and geophysicists have agreed on the existence of a prospect, a potential field. In order to find out if hydrocarbons are indeed trapped in the reservoir rock, we must drill to hit them. Bearing in mind the knowledge acquired about the substratum and the topography of the land, the best position for the installation of the drilling equipment is determined. Generally, it is vertically above the point of maximum thickness of the geological layer suspected of containing hydrocarbons. The drillers then make a hole in conditions that are sometimes difficult. Of small diameter, from 20 to 50 centimeters, this hole will generally go down to a depth of between 2,000 and 4,000 meters. Exceptionally, certain wells exceed 6,000 meters. One of them has even exceeded 11,000 meters. Certain fields can be buried at a depth equivalent to the height of 12 Eiffel Towers. The derrick is the visible part of the drilling rig. It's a metal tower several tens of meters high. It's used to vertically introduce the drill strings down the hole. These drill strings are made up of metallic tubes screwed end to end. They transmit a rotating movement, rotary drilling, to the drilling tool, the drill bit, and help circulate a liquid called mud, because of its appearance, down to the bottom of the well. The drilling rig works like an enormous electric hand drill, of which the derrick would be the body, the drill strings, the drive, and the drilling tool, the drill bit. The most usual tool is an assembly of 3 cones, from which comes the name tricone, in very hard steel, which crushes the rock. Sometimes, when the rock being drilled is very resistant, a single block tool encrusted with diamonds is used. This wears down the rock by abrasion. Through the drill pipes, at the extremity of which the drill bit rotates, a special mud is injected, which the mud engineer prepares and controls. This mud cools the drill bit and consolidates the sides of the borehole. Moreover, it avoids a gushing of oil, gas or water from the layer being drilled by equilibrating the pressure. Finally, the mud cleans the bottom of the well. As it makes its way along the pipes, it carries the rock fragments, cuttings, to the surface. The geologist examines these cuttings to discover the characteristics of the rocks being drilled and to detect eventual shows of hydrocarbons. The cuttings, fragments of rock crushed by the drill bit, are brought back up to the surface by the mud. To obtain information on the characteristics of the rock being drilled, a core sample is taken. The drill bit is replaced by a hollow tool called a core sampler, which extracts a cylindrical sample of several meters of rock. This core supplies data on the nature of the rock, the inclination of the layers, the structure, permeability, porosity, fluid content, and the fossils present. After having drilled a few hundred meters, the explorers and drillers undertake measurements called loggings down the hole by lowering electronic tools into the well to measure the physical parameters of the rock being drilled. These measures validate or invalidate or make more precise the hypotheses put forward earlier about the rocks and the fluids that they contain. The log engineer is responsible for the analysis of the results of the various loggings. The sides of the well are then reinforced by steel tubes screwed end to end. These tubes, called casings, are cemented into the ground. They isolate the various layers encountered. When hydrocarbons are found, and if the pressure is sufficient to allow them to come to the surface naturally, the drillers do a flow check. The oil is allowed to come to the surface during several hours or several days through a calibrated hole. The quantity recovered is measured, as are the changes in pressure at the bottom of the well. In this way, a little more knowledge is gained about the probable productivity of the field. If the field seems promising, the exploration team ends the first discovery well and goes on to drill a second, even several others, several hundred or 1,000 meters further away. In this way, the exploration team is able to refine its knowledge about the characteristics of the field. The decision to stop drilling is made only when all these appraisal wells have provided sufficient information either to give up the exploration or to envisage future production. From 20 to 50 centimeters, this hole will generally go down to a depth of between 2,000 and 4,000 meters. Exceptionally, certain wells exceed 6,000 meters. One of them has even exceeded 11,000 meters. Certain fields can be buried at a depth equivalent to the height of 12 Eiffel Towers.
إذا كنت من المتابعين الجدد، اشترك الآن في القناة ليصلك الجديد بالضغط على الزر الأحمر أسفل القناة مع تفعيل الجرس، ولا تنسوا دعم المقطع بلايك. شكرا لكم جزيل الشكر.